Alright, we're up in the attic over in Stockton, and I want to show some ductwork issues on this existing system. The static pressure is really good, but the return air was a little higher than I really wanted it to be, and the coil was a little high, which I'll show probably later. But the static pressure is part of the reason the return's a little high, and I'll show it right here, is we have kink in the ductwork there, and then also it makes it a very radical turn right there. Should be an elbow on the end of that, so we get better airflow. And it's also just bottom tap, which is okay, but would have been better if it would have been a squared around.
Okay, in this instance, a squared around on the end of the furnace would make much better sense than doing an end tap like they have. It would get much better airflow, as the diagram shows. So whenever possible, use squared arounds whenever you're doing any of these things. Whenever you're doing a furnace, because a squared around is going to make it way better airflow in the system, and that would reduce some of the static they have inside. Now, static's really not excessive on this system, but it is high enough to where we can fix these things, and that's some of the stuff we need to look at as HVAC contractors whenever we're installing a system where we can fix things.
The system looks, it's a York system. The customers complain it's too small. I think it's 2.5 ton. The house is like 2,800 square feet, and it's got the Butler zoning, which was the old two-step type zoning, and this is got 2 dampers.
Even though the static pressure wasn't that high, the drop across the coil is 0.27, which is higher than it should be for a dry coil. So when I select the coil for this new unit, because it's going to go to a 4-ton, we're going to select a coil that has a low rating on it, so we can improve the airflow on the system, because we're not doing much ductwork wise except fixing the return air. So we have to address that portion of it. I'd like to get about a 0.21, 0.23 max on the coil drop, and that's going to fix a lot of the issues on the supply side of it, because if we can fix the return, but we also need to fix the supply side. You got to attack both sides when you do this. And as you can probably, if you take some of my other classes, you'll find that I always pop the door on the furnace to see what happens to the supply side if we have unrestricted airflow. And that usually tells me if I have to fix the air side of it on the supply side, I have to do something on that side of it.
And I have 2 zones for the system, so we're replacing that, putting new zoning in, redoing the plenums, everything. Should fit pretty good up here. Nice little attic, insulated fairly well. So we don't need to add insulation to this house. So it would be nice if we get rid of all the ductboard Ys though. So these Ys, these triangles, they're not real Ys, they're not true Ys. They will restrict airflow. Air goes in, but it doesn't like to come out. So changing these over wouldn't be a bad idea. Something to look at. All right, so here's part of the problem. Kind of ovaled really bad. And it's also, some of it's kinked, and then they got a horn in the middle of it too, which is blocking some of the airflow. So we'll see if we can't fix that. This will be something that we'll take a look at. All right.